Hello friends, this is Vinod from Academy of Hydraulic Engineers. It is a video course on industry hydraulics. This program is designed to impart initial knowledge in industry hydraulics to go further deep in the following functions: design and manufacture of hydraulic power units, cylinders and hydraulic systems, troubleshooting of hydraulic systems and maintenance of hydraulic equipment. The course is designed in 9 sessions which covers following topics: basic principles, hydraulic pumps, hydraulic fluids, control valves, direction, pressure and flow control, actuators, cylinders, motors, hydraulic accessories, accumulators, pressure switch, filters, indicators, reservoir, etc., contamination control, design of hydraulic circuits, and troubleshooting and maintenance of hydraulic systems. Industry Hydraulics, Session 1, Basic Principles, Part 1. What is hydraulics? Hydraulics is a means of power transmission by use of a liquid. When we say power, that involves some forces and movements. So we can define hydraulics as a science which deals with transmission and control of forces and movements by means of a liquid. Since time immemorial, mankind has been utilizing fluid as a source of power. The word hydraulics is derived from the Greek word hydra, which means water. The modern hydraulics works on the principle discovered by a French scientist named Blaise Pascal. And during the course of Industrial Revolution, it was also realized that water was not the best liquid for the hydraulics, and that mineral oil was a far better choice. In today's world, the use of hydraulics became increasingly common, and innovations in the technology became exponentially faster. In the field of hydromechanics is broken down as hydrostatics and hydrodynamics. Hydrostatics deals with the mechanics of still fluid, whereas hydrodynamics deals with the mechanics of moving fluid. An example of hydrostatics is energy transmission in a hydraulic press application, where pressure energy of a static fluid is converted into mechanical energy. Conversion of flow energy in turbines in hydroelectric power plants is an example of hydrodynamics, where movement energy, the kinetic energy of the fluid is converted into mechanical energy, which in turn is converted into electric energy. Apart from hydraulics, there are other methods of energy transmission. They are mechanical, gear, shaft, crank mechanism, etc., electrical, rotating field motor, linear motor, etc., electronic, amplifier, electronic conversion elements, and pneumatic, which is very similar to hydraulics. Here, air is used as transfer element. Now, let us understand some basic terms in hydraulics. Force. A mass of 1 kg creates a weight force of 1 kg on the ground. According to Newton's law, force is equal to mass into acceleration. 1 kg is equal to 1 kg into 9.81 meter per second square. That is equal to 9.81 kg meter per second square. According to SI units, force is stated in Newton. 1 Newton is equal to 1 kg meter per second square. Therefore, 1 kg is equal to 9.81 Newton. In industrial applications, generally the unit used to express force is ton force, which is denoted as TF or MT or simply T. And 1 ton force is equal to 1000 kgf. Force is also stated in pound force, which is denoted as lbf. 1 kgf is equal to 2.205 lbf. Next, pressure. The picture shows a hydraulic cylinder, and inside the cylinder there is a movable piston, and a load is attached to the piston rod. When the fluid comes from the back end, the cap end, it exerts a force on the piston. And when this force is high enough to overcome the load resistance, the piston moves forward. So this fluid force per unit area is called pressure. Pressure is defined as force acting on unit area. P is equal to F by A, where F is equal to force in kgf, A is equal to area in square centimeter, and P is equal to pressure in kgf per square centimeter. In FPS system, the units are as below: F in pounds, A in square inch, and P in PSI, pounds per square inch. Most common units used to express pressure in industrial hydraulics are bar and PSI. 1 bar is equal to 1.02 kgf per square centimeter, or 1 kgf per square centimeter is equal to 0.98 bar. 1 bar is equal to 14.5 psi, and 1 kgf per square centimeter is equal to 14.2 psi. Pressure is also stated as kilopascal and megapascal. 1 bar is equal to 100 kPa, and 1 megapascal is equal to 1000 kPa, that is equal to 10 bar. Work is done when something is moved. Work is directly proportional to the amount of force applied over a given distance according to the following relation. Work is equal to distance into force. The unit of work in SI units is joule. 1 joule is equal to 1 Newton meter. Power. Power is defined as the rate of doing work. Power is equal to work done per unit time. The unit of power is watt. 1 watt is equal to 1 joule per second. That's equal to 1 Newton meter per second. A more common unit of measure of power is horsepower, which is defined as the amount of weight in pounds that a horse could lift 1 foot in 1 second. By experiment, it was found that the average horse could lift 550 pounds 1 foot in 1 second. Consequently, 1 HP is equal to 554 pounds per second. When we convert it into watt, it becomes 746 watt. Pascal's law. Modern hydraulics works on this principle. It states that pressure at any point in a static liquid is the same in every direction, and pressure exerted on an enclosed liquid is transmitted undiminished in every direction, and thus acts with equal force on equal areas at right angles to the containing surface. This is valid with omission of gravity force, which would have to be added according to the fluid level. Now please look at the picture which shows pressure transmission throughout a confined fluid. Point number 1. The bottle is filled with an incompressible liquid. Number 2. A 10 kg force is applied on the stopper of area 1 square centimeter. Point number 3. A pressure of 10 kg per square centimeter is transmitted equally in every direction. Number 4. Results in 10 kg force on every square centimeter of the container wall. And number 5. If the area of the bottom is 10 centimeter square, the entire bottom receives a push of 100 kgf. Transmission of force. The picture shows a confined fluid. A force F1 is equal to 10 kgf is applied to a piston of area A1, that is equal to 2 square centimeter. On the other side, there is a piston of area A2 is equal to 10 centimeter square. Let us assume it lifts a force F2 kgf. Now the pressure exerted by force F1 is P is equal to F1 by A1, that is equal to 10 by 2, that is equal to 5 kgf per square centimeter. Now according to Pascal's law, this pressure is same in every direction. That is, F2 by A2 is equal to P, that is equal to 5 kgf per square centimeter. Therefore F2 is equal to P into A2, that is equal to 5 into 10, that is equal to 50 kgf. So by using the Pascal's law, by applying a small force, we can achieve a large lifting capacity. The picture shows a practical situation of what we have discussed. Session 1 to be continued in part 2. Thank you. Thank you for the kind attention. If you like this video, please subscribe to support and get more videos on not only next sections of this course, but other topics as well.